All right, welcome back to another videos. And in this videos, I'm going to show you how to use Granta Edupack to effectively learn about material properties. So perhaps in your lecture, you have already learned about this material taboo game. And in there, you have learned what is called the material property chart. And so this concept is really good and can be really visualized in this Granta Edupack software that you have access to. So I suggest you to go into it and actually log in and learn about it. So let me just go to the homepage. And in the homepage, if you want to learn about material property, let me click on level 1 for now. When you click on level 1, you can plot material property chart. So let's say I want to click on and I want to understand how different material have different properties of, let's say, so here y-axis, I'm going to try to understand Young modulus. And I want to understand density. When I click on it, I can also click on show family envelope. With that, I can see different type of materials with different type of property coming up. Okay, and in general, we see that Young modulus is actually higher. The higher the density in general, the higher the Young modulus. Okay, it's a general trend, but there are some material that perform better than the other. For example, CFRP. Now, let's say I want to go further and understand material property in general. So, and I want to know what's the difference between medium carbon steel, low carbon steel, and let's say copper. Actually, yeah, let's say I want to understand steel versus aluminum. So I can click on the steel, double click on it, and then it will give me a set of description of what is being used, show you the density, show you the Young modulus, and let's say I go back to the plot and I can click on aluminum, and here you can see the equivalence material property, and you can compare the two. In the plot, you can also see that the Young modulus of the Young modulus of steel is actually higher than the Young modulus of aluminum, but at the same time, steel tend to be heavier than aluminum. And so you can also see that here, Young modulus of steel is 200 gigapascal, whereas aluminum is only 70 gigapascal. You might ask, what is Young modulus? You can read that from the textbook. You can check out the lecture slide, but you can also read it here. Right away, you will get, if you click on a information tab next to each of the material property, you can then go to a science note where it will talk about this material property from both the engineering point of view as well as the science point of view. So drill down the origin of modulus. Turns out the Young modulus actually is governed by the atomic arrangement and the atomic bonds between atoms. And so it makes sense that why, when you have a material that is denser, you will have more atoms that have smaller spacing, and this could affect how many bonds are on average within a materials within the same volume. This affects the Young modulus of the material as well. Of course, the bond will also affect the material. So if you want further details, do read this paragraph, and it will help you a lot to understand how one material can have higher Young modulus than the other. Let's say you want to understand yield strength. Again, click on it, and it will tell you the information about how yield strength are being measured, and drill down to the science of what causes material to have different yield strength. Can we go further? Yeah, there's fracture toughness. We talk about that in the lecture, but here is a summary of what fracture toughness means, how engineers define it, and what's the energy associated with it, and drill down to the science behind the origin of fracture toughness. Very cool. Can we go further? Yes. Now, if you want to know more about electronics and thermal property, here we have some thermal property, but you will have some qualitative data. what you can do is you can change the database to a higher level. So right now we're at level 1, which has less materials and less information, just for you to get familiar with the software. But if you go to level 3, which is more advanced, then you can find a more detailed database. And you can see the material probably chart is now flush with different materials. So what you can do, you can search. Let me see how I can search. Now, here's the search button, and I want to find aluminum. When I search that, turns out there's still a lot of different types of aluminum. I won't go into details what they are, but I'm going to choose one that perhaps is more familiar to people. So I'm going to choose 7075, which is an aerospace alloy. And so with that, you can see the composition, you can see the yield strength, and I want to bring you to the electronic properties here. So you can see here, you can see the electrical resistance, you can see the electrical conductivity, you have magnetic property, optic property, and thermal property. So you can click on other concepts that we will be talking to you about in the lecture. So for example, electrical resistivity, and we'll talk about what it means. You can also learn about shock resistance, and this is something that you will learn from your thermal lecture. And you can read how thermal shock resistance are defined and why they're defined that way. Is there more? Yeah, thermal expansion coefficient. And we will talk about that in the lecture as well. And you can go and click further, and it will talk about how material, why they thermal expand. Well, the reason is because there's an asymmetry of the what we call the potential diagram, atomic potential diagram. And so we'll talk about that in the lecture, but this is a very good extra source for you to consolidate your understanding. Okay. This video, I just want to show you one feature of the Granta Edupack, which is how to learn different material property. Hopefully, you'll find this video informative. So see you soon in your next video. Bye.